to keep a certain distance from the eyepiece. Therefore, when a doctor who does not wear glasses operates, the eye cap should be screwed out a certain distance, but a doctor who wears glasses does not need it, because there is already a distance between the eye and the eyepiece. The objective lens. We have two kinds of them. One with a fixed focal length, like f250mm objective lens with fine focus, which working range around 12mm. The other one is a very distant lens, which has a variable focal length. The focal length can be varied from 190 to 300mm, or even from 200 to 450mm, depends on the models. Its advantage is that there is no need to raise or lower the working distance of the microscope head to achieve focus. You just adjust the focus knob on the very distant lens. You can easily achieve focusing and speed up the work efficiency. As you can see from this table, only OMS 1950 and OMS 2350 are standard fixed focus objectives and can be upgraded to 190 to 300mm very distant lens. Models after OMS 2360 are equipped with an integrated very distant lens as standard, with a working distance 200 to 450mm. It's very important to change the magnification factor to observe a larger field of view at a lower magnification, and to see more details at a higher magnification. In order to find a certain of the objects, it's better to get as large a field of view as possible. There are two solutions for your select: the step magnification change and a continuously zoom magnification changer. The advantages of step magnification change are compact structure, low complexity, but high optical quality and efficiency. The limitation is that magnification can only be selected in steps, and the treatment view is blocked when the magnification changer is being turned. The continuously zoom magnification change is more convenient, very fast to adjust the magnification. The magnification of the object we observe in the eyepiece is the final magnification, which is the final result of imaging by multiple microscope optical elements. The formula used to calculate the final magnification is suitable for microscope with fixed focus objective length. This formula cannot be used for microscopes with very distant lengths because the working distance is not equal to the focal length. Now let's talk about the light source. At present, there are three types of light source used in microscope: xenon light, LED, and halogen light. The main advantage of the xenon light source is that its color temperature is closest to natural daylight. The power is 180 watts, and the approximate service life is 500 hours. The disadvantage is the bulb is expensive. Instead of xenon light, LEDs are currently the most widely used in dental. The color temperature of LED light source is also close to natural daylight, but the light intensity is weaker than xenon light. The biggest advantage of LEDs is their long service life, usually reaching 70,000 hours. Compared with LED light and xenon light, the color temperature of halogen light is much lower. The color present is also yellowish, and when the light intensity changes, the color temperature will also change. And the service life is also one of the disadvantages, about 50 hours. What needs to be emphasized here is that Zumax LEDs are integrated into the head body. Compared with other brands, we no longer need to use optical fiber, because the light source through the optical fiber will be lost, and the optical fiber also has a service life, usually 2 to 3 years. The replacement cost is higher. The new mode of OMS 2380 OMS 3200 microscopes are already equipped with twin light sources as standard, and a second external light source can also be installed, as shown in the figure. However, if you choose a twin light source, you cannot add a fluorescent mode. If you choose a fluorescent mode, there is no twin light mode. It means you can only choose one of them. The lighting illuminance of each mode listed on this table are the result of actual measurement when we have a working distance of 250 mm. The measurement results will vary on different working distance. After installing the second illumination on OMS 3200 R2 and the Pro microscopes, the illuminance will reach up to 210,000 lux. Filters and diaphragms. When the yellow filter is placed on the illuminating light path, it can prevent the composite rising material from cooling prematurely. The green filter can increase the contrast between congested tissue and bloodless tissue, making the details clear. The above two filters are standard on all microscopes. Fluorescence module. After the tooth is infected with carriers, the carrier's bacteria will produce a special purine. This purine will produce red light and the irradiation of blue excitation light. Taking advantage of this characteristic of carriers, the tooth is irradiated with blue light and then filtered. The film filters out the red light, and the human eye or camera can clearly see and distinguish the carriers. Anti-reflective module. When mixing some objects with smooth surfaces or reflective effects, the surface of the object will have a certain specular reflection effect on the illumination light, and the reflective light will be directly received by the human eye or imaging device, and then it will be in the image. A very bright spot appears during the process, which adversely affects the observation effect. At this time, it is necessary to add a polarizer with different directions in the illumination light path and the observation light path to filter out the strong interference light reflected by the mirror. OMS 2360 and the above models are also equipped with microscope. When this illumination spot is selected, the illumination area can be reduced and the imaging contrast can be increased. In the case of high magnification, if the illumination intensity increases, it can help reduce reflected light. During surgery, lasers are often used as treatment tools. Due to the characteristics of lasers, the beam engine is constrained and the brightness is extremely high. Therefore, the user cannot directly observe through the microscope with the naked eye. At this time, it's necessary to install a filter on the operation microscope. Observe only by reducing the transmittance of the corresponding laser waveband. Through this table, you can tell that on various models of microscopes, some filters are standard, some are optional, and some are not applicable. Next part, we will talk about video and recording system. Why use an integrated camera system? The main purpose is to facilitate the archiving of clinic cases and to communicate with patients. And you also need to consider about the assistant. The assistant must be able to see what the doctor sees in order to cooperate with them. In addition to the assistant, if the microscope is equipped with a camera system and connected to a monitor, the assistant can intuitively understand the doctor's working state. Another advantage is that the integrated camera system will not burden the microscope head, making it more flexible when working. Integrated 4K camera is available. for OMS 2380R2, OMS 3200R2 and Pro. HDMI output integrated in the power box at the bottom of microscope basement. Meanwhile, the DVI port on the backboard of first arm output FHD signals. There is 4 USB ports on the backboard, 3 of USB 3.0 and 1 of USB 2.0. U-Disc can be inset into any one of USB 3.0 ports, but only one disc can be used in the same time. Use a codeless mouse, which is a standard configuration, to adjust the 4K camera setting. The receiver of codeless mouse can use any port of the 4 USB ports. Codeless foot pedal set include a mouse, which are optional items. When you use the mouse with foot pedal, please give up the default mouse come with microscope. Move cursor to the left edge of screen to wake up the menu, which with following functions: taking photos, taking videos, reviewing photos, reviewing videos, freeze image, picture comparison. The screen will be divided in 2 parts. Pictures to be compared at A on the left side always, and picture to be compared at B or real-time pictures on the right side. Pictures comparison function is not available for 4K 3D vision. OMS 2380R2, OMS 3200R2 and Pro has 3 shooting methods. Use the buttons on the both handles in any condition to take photo and video, and use foot pedal. Be sure the menu haven't wake up at this time, or click the photo or video button on the screen after menu waking up. Connect a microphone to backboard of first arm. Wake up system menu. Switch on microphone in system status. And synchronous storage of sounds and images available. Please don't review the video directly from the menu, since it's still in mute mode. Please duplicate the video file from your disk to your laptop, then you can enjoy sound video. Start a new U-Disc before using. Wake up the menu. Enter Detail menu, Storage, and U-Disc, then click Format. We can also connect it to a router through an RJ45 port, and transmit wireless signals through the router to mobile phones, notebooks, laptops, and computers, but Zumax software must be installed. 4K 3D camera system with twin 4K cameras. Teaching on presenting in 3D mode, which helps teachers teach and students learn through real-time depth perception. Help patients to understand procedures clearly and bait with 3D videos. Recorded 3D video in a USB memory stick can be viewed on 3D TV, 3D projects, and in VR or AR viewers. Outputting real 3D streaming while the dentists are operating on Microscope Live. Digital visualization. By installing a beam splitter, a certain amount of light can be split into camera from the microscope optical path. Generally, about 20% of the light can be meet the requirements of the photography and video. SLR cameras are mainly divided into full frame and APS. We recommend using lighter and smaller mirrorless cameras, such as Sony Alpha series. Zumax took the lead in launching a mobile phone adapter in 2017 with independent intellectual property rights. The main function is to rotate the image to adjust the angle of a view. It's mainly used for communication between doctors and patients, facilitates online guidance, mutual learning between doctors, and shares go-to social media, such as Facebook, Instagram, etc. Part 8. We will talk about the construction. There are many ways to install the microscope: floor stand with casters, ceiling mount, and wall mount. The most commonly used is the floor stand, and the choice of installation method depends on the site conditions. OMS 2350, OMS 2360, and OMS 2380 series microscopes can be equipped with an extra long arm, but this arm is not recommended for floor-standing microscope because it's prone to tipping when in a spatial position. Both the ceiling mount and the wall mount are fixed in one position and do not need to take up floor space. If customer choose ceiling mount or wall mount installation, you must consider and test the strength of the walls and roofs when planning and design, and avoid possible vibration sources, such as elevators, air conditioners. The vibration sources can spread to microscope and influences image quality. In addition, for ceiling mount installation, the user needed to provide us with two measurement data, the height from the concrete ceiling to the ground and the height from the decorative ceiling to the ground, so that we can calculate the length of the column. At the end of January this year, we launched the latest 3 models of microscopes worldwide. They are upgraded from the original OMS 2380 and OMS 3200 with some new functions. The biggest difference between OMS 3200 Pro and R2 is 6 magnetic bricks and 3 magnetic bricks. The above 3 types of microscopes are all equipped with a fluorescent module and an anti-reflective module and a twin LED light source. Of course, as I have said just now, the twin LED light source and the fluorescent module can only choose one of them, not at the same time. OMS 3200's Bright Plus illumination system 30% auto increased intensity at maximum magnification to get more light for high magnification. When the magnification at the highest, the light spot is the smallest, and when the magnification is at the lowest, the light spot is the largest. OMS 3200 also has a smart moon LCD display. If a vertical eyepiece is installed, the length of the target object can be calculated using a formula. This table helps everyone understand the difference between the new and old models. By now, we have some videos to show you the key points during the microscope installation or setting. Put a flat view under the microscope. Set the magnification changer to the lowest magnification in order to maximize the field of view. Set the focal length of very distant lens to medium. We suggest 250 mm for OMS 1950 and OMS 2350, and 250 to 300 mm for the models OMS 2360 above. Move the microscope up and down for focusing and find the certain position of the target on the monitor. Adjust the interpupillary distance by PD knob slowly and get the 2 images into one. Screw in the eye caps until the silver coil is no longer visible if you wear glasses. Screw out the eye caps with about 2 to 3 silver coils if you don't wear glasses. Set the magnification changer to the highest magnification. Adjust the knob of the objective lens until you view in the most sharpness image on the monitor. At this moment, please do not move the microscope up and down anymore. Adjust the diopter ring until you view in the most sharpness image through eyepieces. First, close your left eye. Adjust the right diopter ring till you view the sharpness image through right eyepiece. Then close your right eye. Adjust the left diopter ring till you view the sharpness image through left eyepiece. After the diopters are set, please do not forget to record them so that they can use the microscope in the future and set their own parameter directly. Set the focal length of very distant lens to medium again. You will get the most sharpness image through eyepieces now. The image resolution on the monitor and the sharpness observed in eyepieces are also the same. Repeat from step 6 if you failed in step 8. If the weight of the arm system changes, such as adding or removing an external camera, the balance system must be readjusted. Contaminated optical surfaces will reduce image quality. In order to protect the optical surface of the microscope from contamination, it is recommended to cover the microscope with a dust cover when not in use. When in use, a protective cover can be added to the objective lens, which is easy to clean. When cleaning, avoid using corrosive or abrasive reagents for cleaning. Use an air gun, air blower, or a cleaning brush that does not contain grease to clean the dust on the lens surface. When cleaning the surface of the objective lens and eyepieces, it's recommended to use a dedicated optical surface cleaner and lens cleaning paper, or use Zumax lens wiper.